Hello and warm welcome to Func Prog Sweden. My name is Magnus and I'm the host and organizer of Func Prog Sweden. Func Prog Sweden is the meetup where we explore functional programming and functional programming concepts and more. Yes. Let's head over to today's agenda then. First, we'll do a short and quick introduction by me, Magnus Sedlacek. And then we'll head over to Azure Cosmos intro with F# by Andrii. And then the second presentation is Business Force, bridging the gap between devs and the business by any means necessary by Wojciech. But first I would like to also thank today's video sponsor, Beat. Beat is a consultancy company having offices in Stockholm and in Ho Chi Minh City, Vietnam. If you would like to know more about Beat, head over to beat.com or check them out on social media. Then let's look at the schedule. First, we're just gonna pop out two things. These are the two meetups we've had so far, and this is today's meetup, 17th of February. As you can see, we're in the February, second month of 2026, and we already have 3 meetups. Tomorrow, we'll have another meetup, and that's just going to be an in-person meetup at Scrive. For those who are interested in Haskell and are in Stockholm, head over to Meetup to sign up and to join the meetup. Then, 17th of March, we'll be at Kivra. That will be both in-person meetup and a meetup where we will also live stream. So if you want to know more, and so please, I think there are still seats available for the Kivra meetup. So make sure to sign up because these meetups usually tend to get full. And then 14th of October, we will run another Func Prog Conf again. We still have some early bird tickets left for Func Prog Conf. And this time it will be a full day. So if you want to buy tickets already now at the early bird price, go over to Func Prog Conf webpage and buy the tickets. Then, of course, if you want to support Func Prog Sweden and you want to be able to spread functional programming and make it more popular, head over to the meetup and join the group and make sure to subscribe on YouTube. And of course, also join the Discord server and an invite to the Discord server. You can find the invite both on YouTube and on Meetup. And in the Discord server, you can ask more elaborate questions and you can discuss with others and you don't miss anything that's going on in the Func Prog Sweden group or general in functional programming. So if you have questions online, please just shoot the questions in the chat and I will read it up to the people or the person presenting. So with that, let's get started. Well, warm welcome Andrii. Andrii is a seasoned professional with over 15 years of experience in cloud and mobile app engineering, architecture, design and integration, specializing in the Microsoft technology stack and OpenID Connect protocol. His journey has taken him through various industries, including constructions, insurance, education and property management maintenance, where he has engineered robust software and IoT solutions. Warm welcome, Andrii, to Func Prog Sweden.
Hi, everyone.
Hello, welcome.
Thank you.
You're warm welcome.
Yeah, nice to see.
Yes.
Nice to see everyone here.
Thank you.
So, should we switch to my presentation?
Yes, we'll open up your presentation and we'll get started.
Okay, perfect. So today we will have a look at Cosmos DB and the library I created for it to simplify its usage. Yeah, just a bit about me. So currently I work in Boardwise and we do board of directors management with F# and MartinDB. Why this topic? So I did 2 production implementations with Cosmos DB. Actually, I have one more. I worked also with Gremlin, but that project not finished yet. Yeah, so it was single tenant app and multi-tenant app. And with all this knowledge, I created this library, which may be useful to you. Yeah. So let's go and see what we are going to look today. First, let's have a look a bit at the distributed database theory. Then have a look what is Cosmos DB and how can we use it, how it's structured, how much does it cost, then how to design data for it, how to work with data, how we can do different programmability within that database, and how we can declare it so we can deploy our resources quickly and easily. And first, let's start from such thing like a CAP theorem. Maybe you know it. So Eric Brewer, which is professor in Berkeley and vice president of infrastructure at Google. So he, in 2000 year on presentation on his speech, he proposed this statement, and in 2002 MIT professors formally proved it, turning it into theorem. So what we have here, we have three characteristics of database management system then that we are interested in, and this theorem tells that it's impossible to guarantee three of them at the same time. Actually, it's pretty simplified statement. That's why later Daniel Abadi, who is a professor at University of Maryland and creator of different database products, he proposed PACE-LC theorem, which tells if we want partition, then we choose between availability and consistency, or otherwise between latency and consistency. Yeah, which is a bit more practical thing that covers more cases. And talking about Cosmos DB, it allows us to choose between consistency in 5 modes, which you can see here, from the most consistent to the least consistent. And this affects pricing, this affects how quick data is stored and appears, yeah. And what's good is you can select it dynamically, yeah. So for example, you choose strong. Strong is it allows you to have data in all the regions at the same time. As you can see on this animation, yeah, this red stuff, it has some gap from the beginning. Yeah, it means that we need some delay, so all the nodes have the same data. And it's the most, this consistency has the most cost, yeah, because you need to reserve wire capacity to transfer data in priority. Yeah, you should pay for it. The next one is bounded staleness, and it's with it we just set the maximum lag between different regions, and Cosmos just follow our intent, yeah, and provides this maximum latency. Next one is a session. So in this case, for example, we need data for some between different groups to appear at the same time. Yeah, then we can specify special session ID, and Cosmos will treat this session as high priority to synchronize. The next one is consistent prefix. It's just guarantees that all the events come in the same order in all regions. And the last one, eventual, no guarantees, just speed. Yeah. Let's go next. So let's dig into Cosmos DB a bit more and start from supported APIs. So this database management system is multimodal. and it supports such APIs. The first one is NoSQL. It's Microsoft proprietary protocol, which allows you to work with documents, but also it has special SQL syntax that you can use to query. Next was is Mongo. What it allows you to do, it allows you to switch between cloud and other Microsoft Cloud and other deployments, yeah, without changing your API. But it's Mongo protocol, and sometimes it even has more features than NoSQL, but it's may vary. The next one is Cassandra. Cassandra is a column storage database, which provides you Cassandra query language. So it's Cassandra compatible deployment. Next one is Gremlin. This is very interesting protocol. It allows you to present your data in terms of edges and nodes, which then you can very easily query with special syntax. And more, it allows you to work with NoSQL too, because Gremlin is just just works on top of NoSQL. So you can connect with Gremlin and you can connect with NoSQL, and you can even read Gremlin documents as regular JSON documents. Yeah, so which is very useful, that you can mix and match. For some data you need graph representation, for other data you need just documents. Yeah, you can work with it together. The next one is table. Azure has table storage, and sometimes you want to have more performance for this table. You want to distribute it between different regions with synchronization. Yeah, you can just switch endpoint, and instead of table storage, go to Cosmos and work with the same code base. And the last one is PostgreSQL, which is Cetus extension that allows to set up it on a multi-node environment. It allows you to define some sharding, and it's completely compatible with PostgreSQL, but it works, it allows you to get more performance. How the account is structured? So it has 4 levels. The first one is account, where you it's like a server, yeah, like a server. The next one is database, which will group your data and define some permissions. Then it's container, which can be analog of which is a table. Yeah, and then you store different items. This can be documents, this can be row, node, edge, etc. Yeah, and so you can use these resources. When you create an account, you get URL, which is unique, and then you can work with HTTPS protocol. Actually, it varies on API you use, but for NoSQL, it's HTTPS. Yeah, and then you have your primary key, secondary key. Also, you have special feature. I'm sorry. Second thing you have is read-only keys. For example, you need some, you can expose, because it's HTTPS, yeah, you can access database from browser. So you can expose this read-only key to browser client and or mobile client and read directly from database. Maybe it's not like very common scenario, but if you can have it, yeah, that's also good. And you can issue resource tokens if you want some limited access to some scopes. Also, the best practice is to use passwordless authentication, but we will go to that a bit later. Let's talk about pricing. How much does it cost? The pricing is based on request units, and this is abstraction that Cosmos DB operates with. And also you pay for storage. You can have several kinds of deployments. First one is provisioned throughput. and it allows you to order some performance. So you tell, okay, I want I want that you provide me 1,000 request units. Yeah, and then Cosmos guarantees you that you will have that 1,000 request units. What is request unit? Request unit is reading a document of size up to 1 kilobyte. When you do some simple query, it's 310 request units. Complex query from 10 to 100. And write is around 510 request units. So this is the math you you may rely on. Also, there is not only fixed throughput, but auto-scale, and it will scale you 10 times. So you define, okay, I want from 500 to 5,000 to 10 times, yeah, from 500 to 5,000, and it will automatically scale you within these boundaries. But it costs a bit more. And the other deployment, which is serverless, and you cannot switch between provisioned and serverless. Yeah, you can switch between manual and auto-scale, but not between provisioned and serverless. What is serverless? Serverless allows you to have pretty much instant scalability, and you pay only for what you use, yeah, what serverless states. But you have some limitations, and one of them is maximum throughput per container, and the other is that this database will be tied to only one region. Because in provisional throughput, you can distribute your database between regions. What does it mean? It means you can have the same data, for example, in North Europe, in Ireland, East US, Australia, and so on. Yeah, and it will be synchronized automatically under the hood. Then let's talk a bit about minimum throughput, which is quite important. So we can choose throughput between container and database. So if we choose container, each container has its own throughput, but minimum is 400. And a minimum auto scale is 1,000, which means it can go down to 100. Yeah, which is pretty good. And if you do it for database, you will have shared throughput between your containers. But minimum again is 400, but 400 it's minimum for when you begin. Yeah, if you have up to 4 containers. But because each container minimum is 100. Yeah, so the formula, if you have 5 containers, your minimum is 500. And with auto scale, pretty much the same. Yeah, you will have this capability. Here you can see cost that you may have for usage. And if we talk about optimization, yeah, if you don't have very heavy load, most probably database level is much better for you because yeah, you will pay only for mixed capacity, mixed throughput. What can be container? It can be collection of documents, it can be table with rows, it can be graph, and all containers share the same infrastructure under the hood. What can we have in container? Of course, we can have items, our data, and also we have storage procedures, user-defined functions, triggers, and interesting stuff is conflicts. So if you have these multiple regions and you write data simultaneously in several regions, which you can do, the data may conflict. And in order to resolve them, you can use this special feature. Yep. Very important note. because it's distributed database and it runs in multiple servers, your programmability is tied to that particular server, which is partition. Yeah, so that means that this programmability will be called, will only work within that partition. What means partition? Yeah, so we have logical and physical partitions. Physical partition is a server, and logical partition, it's how you define what you need to split. We will have a look at it in detail in next slides, but let's also mention that each partition can store up to 50 gigabytes of data, which is quite important because you cannot switch how you partition data after you created it. So choosing choosing how you partition data is very important. Also, you may have another pitfall. Imagine you have 3 physical partitions, and they may be utilized not equally. Why? Because if some data is more frequently accessed in one partition, other partitions may be not underutilized. And even though you order, for example, 30,000 request units, you will only use half of, you will only use a bit more than half of them. So you pay for even less than half of them. You pay for a lot of request units, but don't get them just because you partition data in the wrong way. So it's important to do this design wise. Let's have a look how it works. So in order to fix this issue, with this partitioning, there is one interesting feature with it called hierarchy partition keys. So instead of partition your table by one property of your document, you can do it by several. And all these levels will define you a logical partition at the last level, but then they may be partitioned physically different, and we will have a look at that in images in later slides. So in order to do it, to define these hierarchical partition keys, you have settings multi-hash, and you specify up to 3 levels for partitioning of your data. And then you can query within that partition or other partitions. Let's have a look on it visually. So imagine we have several physical partitions, which are our servers here, and logical partitions that collect documents on them. Then we do some requests, get something where tenant is X. And tenant is our partition key. Then our database know, okay, this tenant ID data is located on that server. Okay, I will go to that server and just grab data from it. Which is good and quick. Then you can specify some other condition, and database know, okay, it's located on this server, and I need only subset of data, so I will go to that server and grab the data. When we define hierarchical partitioning, we may have tenant spread across several servers, which is our first level partition key, and second level, for example, user. So these green boxes represent different users that spread across different servers. What does it allow us? Okay, if we go to filter by tenant, we know which logical partition we need to get. If we specify partitions that is spread across several servers, it's not an issue also because database knows okay, we need to reach not 1, but 2, 3, or 4 servers, however it's spread to, but not all of them, right? Then we can also do some subset. Yeah, we go second level and get data from particular logical partition on a particular server. Yeah, well, sound good. But if we specify a user second level, but not specify first level, database don't know where this user is located. Yeah, because it goes by hierarchy. So it will do a fan out and reach all servers and try to search all servers, which will utilize a lot of request units, yeah, and not good for performance of your database. So don't do that and use this partition keys correctly. Let's have a look at example. Yeah, for example, we have tenant ID, customer ID, and order date, which is pretty good type of partitioning, which allows us to have this distribution pretty equal between different physical partitions. And how to avoid hot partitions? Yeah, the bad choices for partition keys is something that has limited number of values or which has time which bound to time, because, for example, timestamp you always write and read with the most recent partition. Yeah, some category which does not allow you to evenly distribute, and different sequential IDs. That's not a good choice. Pretty good choice is user, but sometimes for user you may need one more level. Yeah, tenant ID, the same stuff. Device ID also. Yeah, for all of them, data may be evenly distributed, may not, depending on your scenario. So in some cases, you would need a synthetic key, which will help you with this situation. But with hierarchical partition keys, you pretty much not need these synthetic keys. Just use several levels and you will be good. What if you made a mistake? Yeah, that's not a big issue because you can move data to another container and partition it another way. Just it will need some time, yeah, depending on the amount of your data, but you can do this pretty easily in UI and repartition your data in another container. So the most important thing to know when you work with Cosmos DB is that storage is much cheaper than compute. Yeah, so denormalizing data is the choice for you, and copying data is not an issue. Yeah, just do it and you will have much less bill than if you try to make your data very, very normalized. When you model the database, you need to answer several questions to you, and the most I think the most recent question would be question number 5 and question number 12. So how big your document is, and should you embed the data or reference it? Yeah, should you split data in several documents, in one container, in several containers, or should you put it together? It depends on your usage scenario. Currently, we live in AI era, yeah, and what to do without vector search? So Cosmos has it, and Microsoft created special algorithm which they provide to you 10 times cheaper than nearest competitor. So with this vector search, you can do pretty much everything that vector databases can do. Yeah, but store data in your Cosmos and don't need separate product to have it working. How you can define it? Yeah, you have vector indexes. You can specify type, not only disk ANN, but other algorithms available. And then you just have special function, which you can use in your queries. And also you can mix and match not only vector distance, but you can do full text search and you can use them together. So pretty flexible capability, which may save you time and money. The other interesting feature for you to save cost is secondary global index. Imagine you have some data and you partitioned it very well, but for some read scenarios, you need to query it with different root filter. Yeah. So in that case, what you can do, you can create secondary index, which is just another container that will have a copy of your data, but partition it another way. And yeah, you will pay for additional storage, you will pay for additional throughput. Yeah, but you may save because your queries will be much more optimized. What you need to do to define it? Yeah, you define like a regular container, its partition key, and also you define the query and the source collection. Okay, I want to get data from others. I want to apply this query, so you can even get not all data, but part of data, and store it in another container. What's impossible in this scenario, you cannot do aggregates. For example, if you have models and here you have manufacturers and you want to have only manufacturers in another container, you cannot do this with this feature, but you can do it manually if you want. And we finished with some basics of Cosmos. Let's have a look how to work with it and work with data. First, how can we query data? The easiest thing is you can read by ID, if you know the ID, and you need to a combination of ID and your partition key. The interesting feature which may allow you to save your request units is read many. So you specify tuples of ID and partition key and pass it to database and get response with your items. Important thing here, you will not get exception if items are not available. You just get only items that are available by this ID and partition key. Also, of course, you can query your documents with queries, and this select statement, it works in a document, and also you can even do joins, but joins again, they work in the same document. Yeah, they don't work like in relational database between containers. No. It all works only in the document. And also you can define queries with link queue. So first you need to get a link queue item queryable for your type that you want to get. Then you specify a query, then you convert it to feed iterator, and you can read by pages. This is how you read the data. What interesting you can do to implement pagination is utilize continuation token. Continuation token allow you to store like a pointer to your data and then query from that pointer. But important note, so first you specify how many items do you want, and when you get page, you can grab continuation token and store it somewhere. Then, oops, sorry. So then what you need to do is you need to define it the same query again. Yeah, query must be the same. You cannot change the query for this continuation token pagination. And after that, you just supply this continuation token and continue from the place you start. If you want something more sophisticated, this is an example of cursor-based pagination. So I created some helpers for me to return data as GraphQL relay response. How does it work? What do we need for pagination? We need to know a pointer, and we need to know we need to sort data by some characteristics. Otherwise, we cannot continue from stable pointer. Yeah, if we have a pointer, and then from that pointer we go forward, yeah, we need this going forward always be the same. Otherwise, it will give you random data, and data, maybe some data missed. Yeah, you don't need that. Yeah, you want the data to be continuous, right? So in order to implement this, you define the values on your document which uniquely identify this document, and from which you can go forward or backward. Then you specify pageable query with partition key, and then you also need to order by these fields. Why? Because you need in order to go forward or backward, all data need to be ordered. Yeah. And then you can convert this to relay connection and return from your API. And this relay connection will be evaluated lazily, because this is how GraphQL works. Then usually you have some data that's located on a sphere or on a surface. And for this, you have spatial data types, which are represented as GeoJSON, and it can be point, and can be different figures. Yeah, and you have functions that allow to work with these primitives. What's was recently added is ordering by this function results. Yeah, previously it worked only in MongoDB, so you can calculate this distance. Yeah, but you can order by this by distance, which was very annoying. Yeah, now it works finally. How do we work with it? We have this function stDistance. We specify from which to which. Yeah, and we get the result. Same thing we can do with LinkQ. For this, we specify, yes, from SDK we have point type. Yeah, and on that point type, we can call method distance and compare it to our value. How do we store data? So in order to store data, we call create item. We pass this item, and the database will get ID from it automatically, and partition key must match on the item and the one you supply. Otherwise, you will get an exception. The other, also you can replace items. When you replace item, you can replace it with another ID. So I can tell, okay, get that item with ID 1 and replace it with new item with ID 5. Yeah, that will work. Another option is to also we have absert. Yeah, if item does not exist, we will create it, and we can even distinguish between what happened: was item created or was item modified by status code. Delete is pretty simple. Yeah. And recent new feature that is very useful is deleting full partition. Yeah, you don't need a partition. Okay, delete full partition with one query. And important thing, I haven't seen this approach in the internet, so this is something which may be new to you and very useful. Sometimes you want to store the same data in one container, but how would you work with it? What you can do, you can define discriminators. Yeah, for different types of your documents, you will define these names or type names that you will use. And what's more, you can even version that, which is very good. Yeah, today you put a document with one structure. Tomorrow you need to update. How would you know that document, which document of which version? Yeah, you must store it on a document. And what do you do next? So next, you can utilize this cool feature of .NET 9, which is JSON-derived type attribute. So first, you define this $type property. Yeah, so property is called, you can call it however you want. I call it discriminator, and I name it in JSON as $type, which is standard name for storing type of the document in JSON. What I can do next, and this is done on my base entity. Yeah, then I will derive from this base entity, and I will apply these attributes that tell .NET that this is base type, but for this base type we have other derived types. And now when we deserialize this base type, it will deserialize it to particular derived type. Also, useful thing is to have discriminator expression, which we can use in queries. And this is an example of derived type attribute. We specify which type will it be and which discriminator will it have. And finally, how we will query that? Yeah, we will specify our discriminator expression. And what we get query something like this. Yeah, we want type that starts with building or complex and deserialize it as a residential property. So in this approach, we can work not only with leaf types, yeah, but we can also work with base types. Okay, give me all residential properties, and then I will match them and work with different residential property types in a single code. Yeah, you don't need separate queries to work with that. And how you can work with versions, you have converters. So on a converter level of your JSON serialization, deserialization, you can deserialize from version 1 to version 2. Yeah, and when you save, you always save to the latest version. Yeah. This way, you can incrementally migrate all your database while you are using. And this is how it may look like in database. Yeah, you had some type of version 1, then you added or removed something, and you store different types of entities. You can even store related entities. For example, we have a building and we have a complex, and buildings and complexes have floors. Why not store them in the same container? Yeah, which may be useful to you because you can read this data together if you want, like constructing one aggregate from root entity and dependent entities. Very interesting and useful operation is patch. You may know what is JSON patch, and this is exactly what we can apply in Cosmos DB. Imagine we have some document and we want to modify only some document, some properties of this document. Yeah, we can do that with this patch operation. So we can change value, we can update value, we can add values to arrays. Yeah, all this works. how do we do that? We have this patch item operation, but important note here. As you can see, you can apply only 10 operations, which is reasonable. Yeah. If you want more than 10, probably you are doing something wrong. Yeah. But you need to take that into account. And one more interesting feature, you can specify filter. Yeah, your data may change it. Okay, so you want to patch some property, but meanwhile, your document may change it. And this patch operations that you apply may only be relevant if another property has some value. Yeah, you can use this filter, yeah, to specify if you want to execute this patch or you don't want when this value changes. And if it's more than 10, yeah, just fall back to reading the item, doing your changes, and replacing the item. You can do it pretty easy with different .NET libraries like more JSON. Yeah, just read your item as JSON node, update this JSON node, and write back as JSON document. Another cool feature is time to live. If your data doesn't need to stay in the database forever, yeah, you can specify when data will be deleted. The all container can have this setting or particular document. And very good feature of Cosmos is it's free for you. So these TTL operations executed when you don't utilize ordered request units. Yeah, when your database is idle, okay, it will do this maintenance and delete your documents that are marked with TTL. And now let's move to my F# Azure Cosmos library and see how we can simplify our life and our code with it. Here you can see create and delete examples. At the top, it's how it's executed with a standard API, and at the bottom you can see my API. What is the difference? In standard API, you need to create options type if you want, and you supply that options and execute the operation. What I created a F# computation expressions for each operations. For example, this create. Yeah, this create, you can specify item and partition key, which is standard stuff you use. But also you have these other properties that you can get with IntelliSense and easily specify on definition. So you see your operation in one block. Yeah, everything that is set to your operation. So and this is captured as operation, and then you pass it for execution. When you execute it, Cosmos have different response codes, and you need to go to documentation and see, okay, for if I do create, it can be created or conflict. Yeah, it can be 2001 or 429, right? Yeah, and you should know that, and you should code it in your code. But in my implementation, you have discriminated union, and you just do simple match. Okay, if it's created, you do create, you do one stuff. Yeah, if it's conflict, you can do anything else. Same stuff for delete. Yeah, for delete, you have also one more setting, which is etag, which represents the hash of your documents that you can match. For example, I want to delete document only if it was not modified. Yeah, I know it's etag, I know it's hash at the point I worked with it. Now I send request to database with this e-tag, and database checks, okay, if e-tag matches, I can delete. If it doesn't match, no, I cannot delete. And of course, you can match with these responses, deleted or not found. Similar stuff with replace and upsert. You have pretty standard set of properties. You have these responses that you can work with, and pretty much the same with upsert. But what if you want to update something on an item, which you cannot use patch, but you want to update multiple properties on a document. For this, you have special helper, which is upsert concurrently. What can it do? You specify what to do if item exists, and what to do if item does not exist. And if it cannot do it, it will just retry and try to apply it again. And all this happens under the hood. And you have another case, which is max retry exceeded if it didn't succeed in a specified numbers of retries. Let's go next, reading. For reading, we have read operation. Usually you need to specify the type. You see read person, you specify the type. Then you can also specify different settings. For example, you want to read document only if it changed. You specify e-tag of the document version you have. If it doesn't match, database will return you nothing. Because it didn't change it. You don't. I have it already. I don't need one more copy. And there are special helpers. You see at the bottom, execute async option, execute async value option. If you want to just have option response, you don't need my discriminated union, just use a simpler way. When you do manual iteration, what you need to do, you specify you get your feed iterator with your query, and then you go through pages and collect your data. But it's a better way. The better way is to use async enumerable. And for this, I have special helper, which is task-seq of Cosmos DB queryable. So you just supply your item link queryable to this function, and you get task-seq and can do whatever you want with this async enumerable. Other helpers, it also can be cancelable. Maybe you want to do the same from feed iterator, and if you want extension method which returns just async enumerable, you have as async enumerable. Also, sometimes you want to count items in a partition. You can do it easily with this function that has optimized query for doing that. You don't need to remember how I need to specify the query to do it right. Also, sometimes you want to check if item exists, which is useful. And sometimes you want soft delete, which will, in this case, execute patch operation, but for you, it looks like delete with specifying the property name. Let's summarize what we have. So we have computation expressions. You can specify, you can define operation, you can store it, and then you can execute it. When you have a result, you can easily match on that and not go to documentation to figure out what cases you need to handle. And if you need some common operations, they just exist as extension methods on container. Now let's go to programmability within the database. What can we do? We can write our stuff in JavaScript, and it will be executed on a server. But how can we work with this JavaScript if we work in .NET? That's pretty easy. What you can do, you can install libman, which is a special library that gets JavaScript code to your project. Something similar to NPM, just without copying all the package content, because usually you need just 1-2 files. Yeah, and here you can see it specifies that I want only index DTS with typings. I don't need anything else. Yeah, let's use it. And you specify JSON config to verify your files in the project with supported ECMAScript. And then you just write JavaScript files in your .NET projects, and they will be verifiable with all the features that are supported in Cosmos DB. Then you can define these programmability features and execute them in your queries. Let's have a look at auto increment. For example, you want you have some document like asset. Yeah, you account asset in your enterprise, and you want continuous numbers on your asset. How would you do that? For that, you need a special document in your container which will hold current value. And in order to maintain this counter, you can utilize a trigger like this. Let's have a look at this trigger. So first I specify types which I will use in my code. Yeah, we have this types, which is asset and auto increment. Asset is our main document. Auto increment is our document that we use to store the counter. And of course, we need partition keys, so we have some properties on these documents. And then when trigger is executed, we get collection, we get a document body from request, and type it with type declared above. Yeah, so that we have IntelliSense and verification. And when we work with this collection, what we do, where we read this document that was created, and if this auto increment exists, if it does not exist, yeah, if it does not exist, what do? We create this document with counter with number 1, yeah, value 1. If it already exists, we increment counter, we put that counter into our asset, we put that counter into counter document, and we store it in the same container. Yeah, this way we can implement auto incremented counter in our documents. Interesting note. So we have pre-triggers and post-triggers. And in SDK, you have property on operation, pre-triggers and post-triggers. But you can execute only one. I don't know why. Maybe Microsoft decided that in future they will support multiple pre-triggers, but currently it's only one. And as I mentioned just a moment ago, you must specify on operation that you want trigger to be executed. They are not automatic, not at all, which is pretty surprising, right? But yeah, it is what it is. So you need to specify them on operation. But from other standpoint, it's logical, because for some documents, we want one trigger. For another documents, we want another triggers. They live in one container. We don't want them to collide, yeah, which is what it designed with. If we want some more sophisticated programmability, we can utilize Azure Functions. And how can we do that? is in Azure function, we define a trigger and we get documents that come to us. And with these documents, we can perform whatever we want. As you can see, we can have them as plain JSON document and work as JSON object. We can deserialize them in our type and work as an object, whatever we need in our logic. Why do we have read-only list? Why do we have a list? Because, for example, we did a lot of changes, but function was disabled, and this change is collected in a special container. Then function runs, and runtime will push multiple items into our function, so we can batch process the items. What else do we do? We can be triggered by other trigger, but consume our Cosmos resources. As you can see, you can inject container, database, or client, depending what you want in your code. If you want to work with one container or two containers, okay, you can put 2 bindings, 3 bindings, whatever you want, and inject container straight away. If you want to be some more dynamic, you can inject database and get containers dynamically. Same stuff with client if you want to work with several databases. How would you output data to a container? For that, you have this Cosmos DB output binding. So you define some output type. On it, you have a property. And in this property, you specify this binding and tell, OK, I want to this data to go to this database, to this container, and specify in this connection string. As you can see, do you see snake case serializable? Why it's snake case serializable? Because in my implementation, I use snake case for document properties. But in Azure Functions, you cannot specify your JSON settings and override the standard naming policy. It will always be Pascal case. Yeah, but you can do some trick and wrap it into a special type, and it will be translated under the hood. When you define it, when you decided how your data should look like, you can define it as a bicep code. Let's have a look how it works. Yeah, so you have this. Oops. So you have this definition. Yeah, you can specify partition keys, unique policies, computed properties, indexing policies, and so on. Pretty much everything, but what you don't see here, you don't see here user-defined procedures, you don't see here triggers, and you don't see here stored procedures. You cannot define them in Bicep. Yeah, the only way to push them to your database is by running code. And passwordless architecture. So, as we have seen before, when we work with Cosmos, we have keys, yeah, which we can specify in our connection stream. But also, another way is to use Entra ID passwordless authentication. How does it work? We specify special credential, and when our code is deployed to Azure, it will act on behalf of the service which this code executes. For example, you have a web app and you have Azure Cosmos database. So you specify permission in Azure that your web app is allowed to connect to your Cosmos database. And in your connection string, you don't need connection string. Yeah, you just need an endpoint URL where your database is located. And you can set up some pretty basic role-based control, just read or write. Yeah, but anyway, it's better than using keys in general. But unfortunately, as I told you before, you will not be able to go without keys at all. Because in order to push your programmability to a database, you need to execute code. And these permissions for this are not exist in Andrii. Yeah, the only way to push your code to your JavaScript programmability code to database is to execute it with a key. How can we work on our local environment or on our CI with Cosmos? That's for that we have emulator. It can be installed as installer. It can be used as Docker image, and it supports all published features. If it's a preview feature, no, it will not support it, but use some, in most cases, it's sufficient for emulator. And it's available on Azure DevOps Agent, so you don't need to install anything. You just execute PowerShell and it boots. Yeah, sometimes. Sometimes it boots, sometimes it not. Yeah, it depends. I don't know what it depends on, but it starts pretty slow, like several minutes. And sometimes this agent is not so powerful and it stick with some timeout, but then you can restart and not a big issue. But how would I create my structure of database if I define it in Bicep? Yeah, I can deploy Bicep to Azure, but I cannot deploy Bicep to my emulator or my Docker image. What should I do? Yeah, for that, in order to fix the situation, I created my own parser. Yeah, it parses my Bicep and it gets data. It gets my stored procedures, functions, triggers from my .NET project and applies that to a database. This is what I use right now. Yeah, it's not published anywhere, but you can reach me if you need this for your project. I can share. And the last thing here, let's check what solution architecture patterns we can use with Cosmos. Of course, it can be plain CRUD operations. Yeah, you don't need anything special for it. We already seen what we can do with this pattern. But let's have a look next. Another option is event sourcing. What you can utilize for event sourcing, you can use Cosmos as event storage. You can use Cosmos as projection storage. You can use Azure Function to build your projections. There is a nice library available, Evenium, which works on Cosmos DB, which I also use, very, very useful thing. But with this approach, we have one issue. If we want to expose native e-tag from our Cosmos DB, we need to know somehow when our aggregate was created. Yeah, and it means we have some lag between we published an event and we had our projection materialized. And it may be an issue. So I didn't want to fix this myself. So I decided to use another pattern, which is transactional box. And it works actually opposite way. First, you write your data and then you publish event with changes. Yeah, which means that your source of truth initially is your data, and then you capture this change as an event. And in order to use this, the best option is to wrap all this work in transaction. So you write your data, you publish event, and these two operations happen in transaction, right? But Cosmos allows you to execute transactions only within your logical partition. Yeah. This means that you need to store your data and your events of that data in the same container and in the same partition, which is okay, but I don't like this approach. Yeah. And in order to overcome this, I decided to work a bit differently, utilizing an Azure function. Let's have a look at this diagram. So what do I do? So I have a secures command. Command creates event in event store, and it stores this event in a special container, Cosmos DB events, with draft flag. When I stored this event, I have its version, and I get it back to command. I set it to my entity, and I save my updated entity, or I create new entity. Yeah, this entity creation triggers my Azure function. Azure function pick this entity and read version, compares to event, and commits my event. This way, I preserve, so I know that my event is only stored if my entity writing succeeded. But what happened if my event was not switched from draft to committed? It has TTL, and in some period of time, it will just be removed automatically. This is how I fixed this issue, where I need to have this data consistent between what I have in my projection and what I have in my events. What happens if someone changes entity manually? Okay, I need to change some data in my entity, something corrupted, something wrong. Yeah, I go to database, I change my entity. Again, it triggers my function, and it just inserts an event that something happened and updates a document version on my entity. Yeah, this way I can even capture my changes which done manually, which, yes, sometimes it may happen, and I think it will be useful. Okay, so let's summarize. The main idea of Cosmos DB, in my mind, is that storage is cheaper than compute. And what you should do is optimize for request unit consumption. Don't do a lot of normalization. The normalization is good. It's a document database. And in order to have the best cost as best performance, monitor your queries, check how much do you consume, optimize, and it will be good for your pocket. What about the library? Yeah, that's a good choice to work with F#, to use computation expressions, which simplify you interaction with it and minimize your cognitive load, and allows you to better handle errors. And that's it from me today. Thank you very much for attending this presentation, and I will be glad to answer your questions.
Thank you very much, Andrei. Thank you. First question, when should you use Cosmos DB? What's your opinion compared to other databases? What's the main use case for Cosmos?
Yeah, good question. So I think that's two scenarios. One scenario is very heavy load. If you have very heavy load, yeah, you can order performance, like very cool performance. This approach of request units, yeah, I order how much I want, and I don't care about anything else. Cosmos just delivers it to me. Yeah, my responsibility is to partition data correctly. All the other stuff is handled for me. Second situation is this is the only database I know which allow you to have multi-region seamless synchronization.
Okay.
Yeah, it depends which regions you deploy to. For example, if you deploy to US and Australia, it may have some complications, yeah. But if it's pretty near, yeah, like different European regions, nearest US, yeah, that's a very good choice if you need this capability. And the last one is if you have very low load. Yeah, in that case, you can also specify, you can set it up to pay very, very little. If you watch, you can watch a short presentation from Cosmos Conf 2025, where some Danish company, they came from using Postgres and paying around $200 per month to just less than $1 a month with Cosmos DB.
Yeah. Another question.
Yeah.
Like which API do you use the most? There were like a lot of APIs. You could have NoSQL, Cassandra, Gremlin. Like what's the one you use the most?
Primarily, I use NoSQL, but I would also recommend you to look at Gremlin, depending on your scenario.
Yeah, okay. Thank you very much, Andrii, and thank you for your presentation, and also thank you for the walkthrough of Cosmos DB. Thank you very much.
Yeah, thanks for having me.
Yes. Yes, then we will go over to our next presenter and our next presentation, Wojciech and Business Force, bridging the gap between devs and the business by any means necessary. Yeah. Warm welcome, Wojciech, to Func Prog Sweden.
Hello.
Hello.
Hello, hello.
Hello.
Can you hear me?
We hear you loud and well. We hear you and see you and hear you.
Perfect.
Yes.
So thanks a lot for having me. And I expect we'll have slides, or yes, we do. Okay, so let me just see if everything works. Yes, it does. Perfect. So I assume then that I can start. And I will talk about business and the gap between it and the devs, which probably doesn't tell you much right now, but hopefully will in a few seconds. So if you read a book or two about public speaking, you will know that you should start a presentation with a story, or your presentation should be the story. So I prepared kind of a story for you. Sorry, we have a technical glitch. I will have to share because the controls don't work as expected. Let me just share my window. Give me a second. Here it comes. Oh yeah, now that it's there. And just a second. It's never that easy. Now my computer will not give Zoom the permission. Like I have to reconnect, so stay here for maybe 30 seconds. I will be back.
Yes, while Wojciech is reconnecting and making sure he can share slides, I can then take the opportunity to push a bit for the Func Prog Conf that will run in October. So 14th of October, we'll run a full-day conference on functional programming. We do still have early bird tickets left, so make sure to head over to Func Prog Conf and get your early bird ticket, because then the price will go up. Welcome back, Wojciech.
Welcome back. Sorry for that. Let me try to do it once again. And now it should work. Let me check. Just one more thing. Yes, I think it's working. Perfect. So, yes, the story. So this is Carl. Carl is a developer. And this is Christine. Christine is a stakeholder, a business person. Carl and Christine don't talk with each other. Carl and Christine built a crappy product. That's it. That's the story. So, yeah, I know it's not very long one. So I have few more. Because I really want you to, before we start talking anything serious, I want you to actually feel what the bridge between developers and the business means, what the gap between them means. And I have two stories from my personal experience that will hopefully make it a little bit clearer. The first story is about fees and other thresholds. So I work in a fintech company. We have a pretty big financial system with a lot of configuration parameters. And in that context, I mean business relevant configuration parameters, like, for example, minimum withdrawal fee, right? So you make a withdrawal out of the platform, you pay some kind of fee, and that's configurable. Now, those parameters were always expressed in the native currency. So if you withdraw euro, you have €5 of minimum fee. If you withdraw USD, you have 5 USD. And that's okay, but turns out those parameters have to be modified every now and then. And it would also be fine, like modified by the business. And it would also be fine if not the fact that we are a crypto company, so we don't have 50 currency, we have 5,000 currencies. And this means that we have those 5,000 minimum withdrawal fees to be updated every now and then. And it's just one of many configuration parameters. And what happened, or like what we learned after some time, we as developers, is that the business side, the treasury team that manages those configs, they had to come up with their own tooling, like a spreadsheet, to calculate all those parameters before they update them. Because turns out they never decide in native currency, they always think in terms of fiat equivalent. So let's say €5 equivalent of the given currency. And this was like wasted work on the tooling. It was wasted effort to use it every time the parameters have to be updated, because we could simply build the system in a way that takes fiat equivalent as a parameter and do the calculation on the fly with some routing and smart logic. And it would be like half a day, maybe more, on the system development, and a lot of time and nuisance saved on the business side. So that's the first example. The second example is also from my current work. And I work in a team called Treasury, Accounting, and Controlling. And one of our responsibilities is we maintain a component called the ledger. It contains all the financial movements of the system. Now, whenever there is a new product, new type of transaction, we have to do something called accounting design. So we need to design how the given product, how the given transaction will be expressed within the ledger. And now this, there is a process for it. Like we sit down as developers with the business and we talk about different interactions that happens in particular product. We craft the so-called movements. But where I'm going with this, in that process, we use a certain specific format of data that we came up with to facilitate it. And it was in place for maybe 5 years, maybe longer. And only recently, we have learned that this format uses completely weird, completely novel terms for the things that are there. So the movement, like in double entry bookkeeping, the movement is from between two accounts. And in accounting, this is called credit and debit account. And those terms have very specific meaning in accounting. But for some reason, developers came up with their own terms, which were from and to, which makes sense for someone who is not an accountant. But this means that in all the sessions where we have to do this accounting design, the business people had to do mental gymnastics to translate between those terms we invented and the terms that they understand. And the translation was not obvious. So yeah, that's the second lesson. And the point I'm trying to make here, and the point I will be trying to make throughout this whole presentation, is that we as developers need to understand the business. We need to understand what we are doing and why we are doing a particular thing. And this comes to it has few different aspects. First, we need to understand the domain, so the problem that we are solving. Then we have to understand our business, so our company, why we do what we do the way we do it. So, for the same problem, there's 5 different companies, they all solve the same problem a little bit differently. So it's good to understand why you do it in a certain way. On top of that, you have to understand the external world, the environment in which you operate. So maybe there are regulations, maybe they are like market conditions. There's a lot of context outside the domain in the business that you need to understand to build good software. And part of it are the users, but they're big enough part to get their own bullet point here. So you need to understand how people will interact with your product and why they use it. And throughout my career, I had the observation that we don't understand enough. We don't put enough emphasis on that part. So that's why we have this presentation. Okay, before we move forward, I have to do a small warning. There will be very little code in that presentation. I put some there, and this is a programming presentation. There will be a lot of programming terms, but very little code. So just a warning to be prepared. So now let's step back and try to understand why this is how it is. So I think that developers focus a lot on technology. So the things like error handling, compiler features, effect systems, JSON parsing, tooling, category theory, syntax, databases, scalability, performance, architecture, security, testing, and of course, drama. So we like those things. And I think this might be even more present in functional programming communities than the others, but I don't have any data on that. But I think all languages, all communities are affected. And what's worse, we idolize those technicalities, because the more often something is mentioned in a conference talk, in the documentation, in the library marketing, the more value we assign to it. We see it as more important, which is normal. It's how psychology works. But then reality hits, and turns out that all those things don't matter for the business people. At least they don't matter directly. The business folks will never come to you and say, you should have better error handling. No, those things matter indirectly through long chain of proxies. For example, the business might say we need high uptime for the users. We should never the service should not go down, and it might to some extent map to error handling, but it's just part of the picture. And what's worse, we often don't understand those chain of proxies because it's not easy. And in the end, what matters is how quickly and cheaply you can solve real problems. That's what most of the businesses care about. And we need to learn how to translate the things that we care about into those things that they care about. And because it's not always the same, on many occasions, the developers build a perfectly safe, performant, maintainable solution that's maybe decommissioned within months because no one uses it, or no one uses it because it solves the wrong problem. And it solves the wrong problem because we don't understand why we are doing what we're doing. Okay, now I have to say the opposite is extreme is also bad. So there are under-engineered systems, and it's a big risk. As a lot depends on the domain. So in the financial or healthcare or similar high-stakes domains, you need more reliability. But in general, yes, the technical excellence matters, but it's less common for lack of technical excellence to manifest, because a lot of projects will fail before hitting technical issues. For example, you need a certain scale to hit performance or scalability issues. Okay, so how can we do better? And here is where Business for Us comes from. And then the next few slides, or maybe the rest of the presentation, will be sort of a sales talk. So I'm not going to sell you anything. There is no money involved. I just will try to present you the solution that I try to came up with to that problem. So what is Business for Us? Business for Us, if you don't know, the 4S stands for Scala. And it's an ecosystem of business-oriented tools written in Scala, meant to be used from Scala with the functional programming at its heart, that solve some high-level business-relevant problems. We'll come back to this, what those problems are, what those tools are in a second. It's also a community, because the software is not created by individuals. Programming might be done by individuals, but software engineering is a team sport. So this is also a community where you can discuss, educate each other, help each other, and create stuff together. And on top of that, it's also a counterweight to the technical side of Scala. So I've been in the community for more than a decade now. I've been to a lot of conferences, and there is a lot of emphasis on the technical side of things. So I wanted to give something that will show up on, let's say, social media or conference or meetup every now and then, and slightly redirect people back to what's important to the business problems. So yeah. And when we take another step back, it's also a plot, not very hidden or obscure one, but a plot, a scheme to transform how Scala developers and the Scala language as a whole is perceived in the wider world. So and it's a big goal, but we are getting that slowly. I want Scala to be perceived as a functional language for boring software. And why boring? We'll get that close to the end of the talk. So with all that introduction, now we can talk a bit on what are the projects within the Business for Us ecosystem and how they help bridging that gap between developers and the business. But before I do that, I have to take another step back. So we need to understand why devs and the business don't talk with each other. And that's mostly because they speak different languages. I don't know how many of you have experienced that, but if you talk with the business, they don't understand terms like a commit, a pull request, high availability, and things like that. But they might speak their own jargon, and they might use terms that you don't understand. Another issue is that the gap comes from the fact that they see different part of the picture. So, for example, if you talk with a support agent, they have visibility into the user problems, and that's probably not something that you see as a developer, unless you're, I don't know, L3 support. Or if you go to talk with accountants or like finance people, they will see regulators or like the government officials that talk with your company. And that's definitely not something you will experience as a developer. So you just see a different picture. And we care about different things. So we as developers, we care about what's our responsibility. So keeping code clean, keeping it bug-free, keeping it performant, right? And the business might care about, keeping the company compliant, for example, or keeping users happy. But in the end, the good news is that we have a common goal. Both the developers and the business folks want to build a useful, successful system. So the question is, how do we bring them together? How do we get to that goal? And we do it with tools. We are developers, we write tools. So that's why we have the projects in the Business for Us ecosystem. They aim to close that gap to allow people to solve certain problems in a way that will allow both sides to see it in the same way. Okay, now a small disclaimer. The stuff that I will talk about, some of them exist and are production ready, and some of them are maybe not even an idea well formed. So there will be a spectrum of those when we go for it. So okay, so the first project on the list is Workflows for Us, and this is a library. And that's important part. It's a library, not a framework, not a tool, not a standalone anything. It's a library for expressing long-running persistent processes, and often called workflows. And if this doesn't tell you much, it's basically any series of steps that might take, like have to happen, that might take days or weeks in total, which means your service, your system might go down in the meantime. Like you will have a deployment, so you have to somehow persist the state of the process across time. And this is if you worked with something like temporal or AWS step functions or Camunda, that's more or less a direct replacement. How it's different is that, first of all, it comes with the first class support for visualizations. Because, as I said, we need to talk with our stakeholders. We need to talk with our business folks. And this means we need something to, like some common ground to understand each other. And this is one of them. So we have those diagrams that tell you how the workflow looks like. And this is generated directly from your code. There is no way for this to diverge. You just need to make sure to regenerate the visualization when you change the code. And it has actually not one but two modes of visualization. The first one was Mermaid and the flowchart. The second one is something called BPMN. Some of you might not have heard about it. It stands for Business Process Modeling Notation, which is a standard from 10 years ago, but this is something quite widely used in certain communities, and this is designed exactly for that, for showing the business processes. So we can render BPMN out of it, out of the code we write with workflows for us. A small comment to that is that the format is great, but the tooling around is not. It's really not great. I don't like it. I didn't like developing support for it, but I still do it and I still maintain it because it's an important attachment to the business world. Like there are people who use it, who care about it, and we need to understand them, and this is why we also have this, which is kind of a technical thing. We could say a single visualization is enough. Okay, the next thing. Okay, and there is a first and one of few snippets in the slides. We also have a drafting support. So it's not enough that you can create your workflow in code. It's not enough that you can visualize it, because if it happens after weeks or months after you start working on something, it's wrong. You need to talk with your stakeholders early as possible. And that's why we have the drafting support. And what it means is you can construct the workflow in a very similar way to how you would do the real one. It will use the same internal representation, just with certain things omitted, hard-coded, and things like that. And you can gradually implement it step by step, while the visualization, for example, keeps working. Another feature it has is the introspection. So when you run your workflow, you want to see what happened, like which path it took for a particular instance, for a particular execution. And we as developers, we have tools for that, okay? So we have logs. We can go and see and understand how the system behaved. But our business folks don't have that. So for that particular reason, so that we can have this conversation together, we have the introspection support, which tells you what happened. But this on its own, it's almost like half-baked solution. And to complement it, we also have a web UI. So this is a separate component. you have to expose an API that we also provide. You have to expose the UI that we provide as a bundle. But then you have a pre-made dashboard that you can look, or your business can look at, and see both the shape of the workflow statically, but also look into the particular instance and how it executed. By the way, the UI is also written in Scala, so many of you might not come from the Scala background, so Scala can be compiled to JVM usually, but it can also be compiled to Scala.js, and that's how the web UI is built. Yeah. So that's now a little bit of code, because I want you to actually trust me that this is a proper programming thingy. So this is a very simplified view on how the workflows for us is written. So we have the seal trait, so basically an ADT that has 3 type parameters: input, error, and output. And then we have a bunch of variants of that sealed trait. For example, when you sequence stuff, you have a first one, and the second one, which input is the output of the first one. This is kind of obvious. The more interesting thing is what we do with side effects. So whenever we run side effects, we create an event. So workflows for us is an event-sourced solution. Whenever there is a side effect, we produce an event, and only from the event we produce the error and the output. What happens on the recovery, what happens when your system dies, is that we replay all the events stored in the journal, reconstruct the state, and can execute the stuff again. And there is a link there in the slides to the whole presentation on about internals of workflows for us from Scala conference last year. I will share the link to the slides and to anything. You will find it there if you're more interested. Okay, enough about that. Another project. So another project is decisions for us. And this is something that allows you to express rules, express complicated conditional logic without a fully blown rule engine. And what it means. You write a bunch of code, which I somewhat intentionally omitted, and you get this rendered out of your code. So what it is, it's a DMN, decision modeling notation table, that tells you what are the rules guiding a given decision. So you have input parameters, you have output parameters. So for example, here, if you look carefully enough, you will see that if number of approvals is bigger than 0 and the target branch is not protected, then we allow merging. Or if the author is admin, we allow merging anyway, but we notify that unusual action took place. And that format is somewhat understandable by the business, at least more than the code would have been, which is what we want. We want a common ground to hold a discussion with non-technical people. So what else we provide is diagnostics. Because all of that is declarative, we can tell you for each evaluation why exactly we took a given decision. So for a given input, we know that the rule 0 was not satisfied because the second condition was not satisfied. And this also gives something that non-technical people can understand with a little bit of effort. Okay, another thing we have is domain-oriented Scala style guide, because many ways to write the same code, and we wanted to give some advice to the people of how to write code that puts domain first. And I have two examples taken out of it. There's not a lot there, but I took two things to showcase the idea. So most of us work in the Western culture. We write and read from left to right. And what it means is that what stands in the beginning of the line is read more often. When we skim through the code, we look at the beginning of the lines. When we read the code, we read from the beginning. And if we want for the logic to focus on the actual business logic, that logic has to be in front of the line. And this might sound obvious, but a lot of Scala code bases do not follow this practice. So what is against this practice is putting the wrapping in our, let's say, IO or IDERT or any other helper construct at the beginning of the line instead of using suffixes. So that's one example. Another example is how, when you organize your code base, especially when you have a lot of different domains within the same project, you should split it by domain first and by technicalities later, not the other way around. Okay, so now a small digression. What's behind the scenes of your business? Like, take any bigger company, and you will see that there's a lot of operational folks doing things 7 days a week just to keep the company running, or 5 days a week, depending on the business. And those people use something. They either use web UIs, so-called back office UIs, or they use spreadsheets. So how can we help with that? So we have a library called Forms for S, which is meant for rapid UI development. And this is just a fancy way of saying we generate web forms directly from your code, from your data types, and allow you to render it with few lines of code within Scala.js environment. The goal here is to make it as easy and effortless to build the back office UI for your business as possible. Another project that I'm working very actively on right now that should be released this month, I hope, is ChatOps for us. So web UIs are okay, but more often than not, they stay in the way of the people. Like, they have to go to the browser, find the right page, find the right action, click something, type something, and then do what they have to do. At the same time, a lot of them are actively engaged in conversation throughout the day on Slack. So what if we move the things they have to do into, let's say, Slack, into the message platform that they use? And ChatOps for us aims to simplify exactly that. So you go, and with a couple of lines of code, you have a fully working process based on Slack messages, buttons, forms, commands, whatever. So if that sounds a bit vague, imagine the approval process, like basically any kind of 4 eyes policy, maker, checker thingy. So one person does one thing and the second does a thing, and the second person has to approve it. You don't want this to, you want this to be fast, reactive, so why not do it in Slack? And that's exactly what ChatOps for us will allow you to do. It's possible right now. You can use Slack SDK, but like often it's too much work to understand the SDK, too much work to use it, to handle some edge cases, to handle the infra. So ChatOps for us aims to simplify that. Okay. Now, one more digression. Let's talk about the elephant in the room, the domain-driven design. You may have heard about it, you might have not. I think it's more popular in the open object-oriented world than in the functional programming world. But its initial premise was exactly about that. We need to get closer to the business. And I have a mixed opinion, mixed relation with domain-driven design, to be honest, because it has two very, very important, very useful concepts, which is one is ubiquitous language, and the second is bounded context. Ubiquitous language is basically tells you that you should use the same terms that your business used to explain things in the code. The bounded context means that you need to identify like spheres that in which the terms mean something, but might need to be translated to something else on the boundary. So, for example, a payment might mean something in accounting, then in the payment processing. Like in one domain, it might be a withdrawal or a deposit. In other, it might be an invoice being paid. And both those domains might use the same word for it, but they are different terms. They have different meaning. But then there is a lot of space, and there is everything else in the domain-driven design, which is like aggregates, value objects, factories, and God knows what. And all of that, at least for me, have very little usability. Like it's not very useful. That being said, we do have a project that touches a little bit on domain-driven design, and that's Domain Docs for S. That project is being also actively developed. We are kind of in a research phase trying to figure out what will be a good product to build there, what are the good features. But what's the goal is you should be able to generate some high-level documentation that can be read by non-technical people from your code. So, for example, DDD glossary, so the list of terms with definitions that you use to give a page that will match to this concept of ubiquitous language. Okay, so that's pretty much what we have, but there is still more things we could be doing. So there is mentorship program, because as I said in the beginning, the software is not created in isolation, it's a team sport. So there is a program to help people grow and embrace the mindset more. It's on pause right now, but I really hope to revive it one day. You can still apply. There was a proof of concept of a solution to the problem of A/B tests. So, serving functionality, the one version of functionality to the one group of users and another version to another group. And this is like, there are ways to make it happen. It's a lot of work to make something actually usable. So the project is on hold. Another thing is more technical and still something that is only an idea for now, but this is SSO for S, so single sign-on, some support for things like, Google OAuth or OneLogin, Okta, whatever you use for authentication in your business, in your back office. So yeah, I almost started working on it, but then decided different priorities are more important. Another thing is spreadsheets for us, and that's here more as just a pure idea, not even well-formed one. But throughout my career, I was fighting with spreadsheets a lot. I was trying to eradicate spreadsheets as much as I could because they are error prone, they are unsophisticated, they don't allow you to do things the way you do it. And I lost that battle over and over every time. So my take right now is that you cannot win with it, and if you cannot win with someone, join them. So maybe there is something we could build to actually make living with spreadsheet a little bit easier, better, to build solutions around it a little bit easier. Another idea that I want to execute is to the business-oriented benchmark. So I have a thesis that the performance of our system don't really matter in the grand scheme of things. We really like to talk about performance, but for majority of systems, it's probably less important than we think, and the same code written in different languages will actually take the same amount of infra or cost a very similar amount in terms of infrastructure. And then what becomes important is more maintainability, expressiveness, how costly is building the software, how costly is modifying it, maintaining it, and that's how we can get to the things like, immutability, type safety, and all of that. So that's something I want to do. I want to verify that hypothesis by building a benchmark that will focus on like number of concurrent users and something and the cost of actual machines rather than artificial numbers like requests per second. Okay, so that's pretty much it in terms of projects. And the next thing I wanted to say is the technical complexity is still there. It's not like those tools are simple. So, for example, the workflows for us with which we started, it has like generalized algebraic data types. It has a couple of class lists running around. We use a state monad in one place. It has tagless final for effect agnostic operations. It's built on top of event sourcing with some support for data sharding and distributed logs. Decisions for us. It's built on top of higher kind of data. It makes extensive use of polymorphic functions, type lambdas, type class derivation. It has its own expression DSL. Domain docs for us that I explained, it works on top of Tasty, which is like a low-level compiler output intermediary format between the compiler and the actual runtime code. So there is a lot of those technical aspects there that are cool. I did presentations on those to some extent. But at the same time, the point of this presentation is that then all those technicalities don't matter in the grand scheme of things. If I could build the same products, the same stuff without all that complexity, I would gladly do so. Unfortunately, as far as I'm concerned, that's not possible. The tools are usable only thanks to those things and to what Scala provides. Another small digression, and I promise we're getting to the end, is that the code is the way to go. Because you might ask yourself, why not use something that is business first, allows the non-technical people to create things in a sort of visual environment. So for example, with Camunda, you can have a visual editor and create a workflow, like almost implement a workflow without any technical expertise. Or you can use any other tool in a similar way. And I tried those tools. And all those attempts failed miserably across all the attempts. And my answer to why is that, first of all, business people, non-technical people don't have the tools to do those things properly. They don't have a good editors, the good debuggers, the good testing harness, and this jeopardizes all the attempts for them to create any significant executable logic. The next thing, even if they do have the tools, because they can be built either in-house or they are already there, is the expertise. So the business people, they are not software engineers. They don't have the expertise that we do on how to build reliable software. So whatever they build, it might not be to the same standard as we would do it. But even if they do have the expertise, or just that they somehow manage to do a good thing, another obstacle is that they often don't have the will. Like they have their own area of expertise, their own world to take care of. They don't want to be bothered with building the systems. They just want to use them. They want the system to serve them. And yeah, even if they do have the will, because they are weird, they probably don't have the time, because yeah, they have all other duties of not being a software engineer. And the same applies to the era of AI. So we write a lot of code with agents today, at least I do. And this brings the question, are this kind of tools still important? Still, yeah, we still need to care about them. Can't we just invent a new workflow engine on a whim when we need it? And the answer is yes, we can. But the problem is that AI, to be used effectively, has to be constrained. It has to operate in as restrictive environment as possible, so it can focus on the core. So the more type safety we bring to the equation, the more immutability, the more harness in terms of a framework or linters or anything else we add to the picture, the better AI will perform, at least in my experience. So giving it a structured approach to, let's say, workflows or decisions like rules or anything else, increases its effectiveness, how much time it needs to build stuff, how much tokens we spend on it, and all things like that. Okay, so I told you we'll get to this. So one of the things I want to leave with you is that boring is good. Like we in functional programming communities have a tendency to look into fancy stuff, maybe even academia level fancy stuff, which is fine, because from there we get innovation and nice things. But at the same time, we need to remember that the boring is actually valuable. Boring tools, boring domains, boring software. That's why there was this initiative, I think, in Haskell, called boring Haskell. Just use whatever gets the job done without focusing on technicalities too much. And that's why I said I think Scala can be the go-to language for the boring real-world software. We have really good foundations to make it so. The language is really powerful. It has a really big ecosystem, not only its own, but also we can piggyback on Java. So the foundations are there, the tools are coming, and it's just now about the perception and kind of spreading the news. And of course, building this is not very easy. So we need more ideas, we need more feedback, more adoption, more leaders. So if what you have seen sounded interesting, then come to our Discord, come to me directly. There's probably something you can contribute, or like even by trying to use it, it's already a big contribution because we need the feedback and usage reports. So that's all I had for today. And the final thought here is focus on the business. So whatever you do, try to every now and then step back and try to and remember why you're doing what you're doing. What is the goal? What is the minimal amount of effort to get the job done? Thank you.
Thank you very much, Wojciech. Very interesting presentation, and also very good. I think you're spot on. I mean, this is the number one issue or problem or challenge in every place I've been. It's like speaking the communication between the business people or domain experts and the developers, or the developing team, in a sense. Yeah. One question directly from the chat here is like, what would be the best way for the domain experts to present to the developers what the domain is? Can you say that there is one formula or way to do it, or is it dependent on the domain?
That's a very good question, to which I don't have a good answer. So it's very much, at least in my experience, it's very much case by case. And the only advice I can give is a very non-technical one. Try to be as close to your domain experts as possible. And like by be, I mean have a chit chat with them, like coffee chats, spend time together. If you go to if you're a remote company, go to spend time on the retreat together, talk with them on anything, like, kids, hobbies, all that stuff. And when you build a relation, the cooperation is much smoother. So it doesn't answer the original question, but I think this is a general improvement you can do to when you have those conversations. Everything goes much smoother then.
Yes. So collaboration and communication is the number one go-to then.
Yeah.
Yeah. Cool. Then also, if your application is not written in Scala, you have to rewrite it in some other language, what you've done. What of the 4 S's would you start with? What's the most bang for the buck? Like, this is what you should do then.
I think the one, when I started the whole initiative, the first library that I've built was the decisions for us. So the one about the rules, the conditional logic, mostly because this was it's very small, and I think it's the most it's small both from the point of view of the library code. You don't need to write that much, but it's also small. It leaves a small footprint on the system being integrated into. So you use it, you replace a single if condition with a rules, with a decision table. And it really changes how you look at business logic. Like, it gives you the tool to make it visible. It gives you a tool to actually make it meaningful. It's not like some auxiliary part of the system, one of many. You can get a piece of it and tell this is important. And then on top of it, you can go to the business, show it to them, discuss it. And it doesn't take much effort. So if I was to focus on the one thing, I think this has the best cost to value ratio.
Thanks. Also, how's the perception been of the tools in the business side of people, non-coding people, in a sense?
Generally, every time I came up with the artifact of those libraries to the business, they were impressed to some extent. Like, they liked it, mostly because some of the problems were like, at least on a few occasions, I visualized the logic that was a source of the discussions for years at this point. So they were happy that now they can actually see what's in the code.
Yeah.
At the same time, I have an impression that it's still like you still have to force them kind of to consume those artifacts. It's not like they will be eager to do it. Like it's useful to them. They are happy. I'm telling from the interactions I had, but at the same time, it's not like they will from now every day look at what you've built. They still have their own responsibilities, their own tasks. So you just need to put it in their way, in the sense that it has to be easily accessible for them to actually use it and take value out of it.
Yeah. Also, have you seen kind of in your company or where you use the tool, have you seen like do you get better, what do you call it, like turnaround times from like less, what do you call it, like requirement errors or like just lack of, I don't know, understanding the issue, building something that's not right? Have you like kind of seen less of that or?
Yes, I had a few cases where I used either decisions for us because like it's very simple to write the rules there, or drafting in the workflows for us, just to sketch something that we either didn't build in the end or that we modified heavily. So it was like, after half a day I had this and we hold a conversation, and then we were able to chat about it.
Okay, thank you very much, Wojciech, and thanks for your presentation. We'll also put out the links, of course, to all the libraries and etc. in the show notes. Yeah. So thanks again.
Thanks a lot.
And thanks for joining. Yes, thanks for joining, and have a nice evening.
Bye bye.
Bye bye. And thank you very much, everyone, for watching Func Prog Sweden and joining in. And as a summary note, if you want to present at the meetup or if you want to sponsor a meetup, feel free to reach out to me, Magnus, on LinkedIn or X or wherever you find me. Just ping me, especially if you want to come on and present, then you should really ping us. You don't have to be an expert to come on and present. Just if it's your first time you would do a presentation, you're warm welcome to come on and do a presentation. Yes, and with that, we would like to say thank you, and until next time, have a pleasant time. Goodbye.